using the scroll wheel on your mouse, and you can also move it using a right click in this camera reticle. So if we click on this side of the red line, you'll see that the laser moves in that direction, and we can just go around different points on this little cross until we get it close to the center. We can zoom out. You can also fine-tune that, like I said, using the test tab over here. We can then use the Y up or Y down, and the speed that it travels is here. So if you really want it to go slow, you can put in 1 millimeter a second and just move it 1 millimeter a second. The difference is now this still says an offset of 1. So if we want to have just continuous movement rather than an offset, we can go continuous movement and it will just move a little bit at a time. So you can adjust using these buttons. Now once you've got it close to center, then that's ready to go to the next step. So click on the setting button and enter the CCD calibration. All right, when you open up the CCD camera parameters, you can see that you can see the camera, you can adjust the contrast, the gain. You can also have continuous auto exposure. So this will adjust if the lighting in the area that you're working in adjusts. You can leave continuous on, but you can also adjust your exposure and things like that here. You can also rotate the image. So if this that you're seeing was not clear or upside down, we could adjust it 180 degrees to make sure that the orientation is correct. So if it was set on 0, that's how it is in my machine, but I've adjusted it to 180 degrees. So again, we need to make sure that we have a clear image. Now using the adjustments here, we can view the screen and adjust the focus, the brightness, the white balance, the auto exposure, that sort of thing, until you get a nice clear image so that the camera can pick up those mark points effectively. So now we have a nice clear dot that we're going to work with. Now this dot is 6 millimeters, so we're going to start the calibration. So that we type that down here, we type in 6 millimeters. We're not going to cut the circle because we've already got a circle printed, so the circle is going to be 6 millimeters. Now for this graph length, what we do is we drag in this green box using the mouse to the edges of our circle. So we know that this circle is 6 millimeters printed, so we move these green boxes right to the edge and we adjust it as close as possible to the center so that we get a nice measurement. Zooming out with the scroll wheel, we can then also adjust this down. Just drag that one down and we zoom in. So we want to make sure that the whole circle is encompassed by this green box and that no part of the circle is outside of it. Now you'll see on the side here that it will show that this is measuring at 10.53 millimeters. So we go down to the graph length and enter in 10.53. We calculate that and we do a match test. It will pop up with this box saying the circle diameter equals 5.773. So we record that and we type in here 5.773. We calculate it and then we do another match test. Now we can see that the circle diameter equals 6. So that's successfully calibrated the size. Now you just keep going through this procedure of entering in the graph length and the match test until you're as close to 6 as possible. It may be 6.001 or 002, that doesn't matter, get it as close as you can, and then that is the calibration of the size completed. The next step is calibrating the offset between the camera view and the laser head. So what we do here now is we move the laser head to a clear piece of material. I'm just going to cut over here on the pine or the timber, and you can see my field of view there. We can extend this field of view up and out again now. We can have it so that this is where the camera will detect And now what we're going to do is set a cross size of say 30 millimeters, and we will actually press cut cross. The laser will then cut the cross and the camera will go over the top of it. Now this could be quite a long way out, but the idea is that we get this reticle of the camera directly over the cross that is just being cut. So we zoom in, and again using the same steps with either using the right mouse click or by using the axis move buttons, we want to get as close as we can to the center of that cross. So we can zoom all the way in to get the highest accuracy. Now when I'm moving here, just a reminder, I'm using continuous movement with a speed of 1 just to keep things really slow so that I can adjust, fine tune it. If I want to fine tune it even more and say, well, a 1 millimeter or 1 millimeter a second is too much, or I want an offset of 0.1 of a millimeter, I could then turn the continuous movement off and I would move only 0.01 of a millimeter in each direction. So you can fine tune that and get it as close as you can to the center of that cross. Once you've done that, you press on the calibration and that will then pop up and say success. So as you saw last time, when we cut the cross, it didn't quite overlap properly, so we're going to redo that. So we move the laser again to a clear piece of material and we cut that cross again. And you can see now when we zoom in that it's gone directly over the top of that cross. So that is your calibration complete. If you need to fine tune, you can actually fine tune it even further and press calibration and then recheck. Now it's a very good idea to export your calibration files so that if you do change computers or if you need to reload the software, you can just import the calibration file without the need to redo your calibration every time. So we're just going to call this MW laser 1610 and then whatever date or time or whichever machine that it's attached to. Save that file. So next time if you were to load the calibration and the calibration was out, we could import that calibration file and we know that that is now correct. And you can check it after you've imported it, again by going to a clear piece of material, cutting the cross and seeing if it's over the top. We can also check the size calibration again either by using a printout or we can actually tell it to do a circle cut. So we might cut a circle that is 30 millimeters. We will cut that circle. The camera will go over the top of it. We zoom out. We tell it that the circle is 30 millimeters and we do a match test. It will calculate it and say it's 29.118. So if we want to fine tune that any further, we can. Just remember that obviously the line is either on the inside or the outside. So some of these deviations in values could be the thickness of that line. That's why I like to use a printed copy. So if you wanted to do a match test on this little dot again, we could tell it that the size is 6 over here and do a match test and it will come up and say it's 6.025. So we know that our size is correct and our positioning is correct. Okay, so now we're just going to do a test. So what I've done is I've printed out an A4 piece of paper with some shapes and some mark points. You can see that there. So now what we can do is using the file